So, resolution of a vector. Resolution of vector is breaking up a vector into components. It is kind of like using a parallelogram law in reverse. You had two vectors, you were joining them together, from the tail, and you were drawing a parallelogram. So once you had a parallelogram, you figured out the triangle, and you used sine cosine law. Okay, so you had two components, and you found the resultant out. Okay, so here you've got the resultant, and it's saying that find the two components out. Okay, the resultant force, my resultant force is, let's say, 820 Newton, but it's the result of two forces, my weight and this book. So now it's saying what is the force of the book and Dr. Mufti. Okay, so it's basically now in the opposite direction. You got the resultant force, and you need to find the component forces. So that's basically the breaking up of a vector, and it's relatively easy. You got one vector. Draw two perpendicular lines to it. Okay, two perpendicular lines. I'll use this as a white sheet. So I have got a vector here. Okay, and I can draw two perpendicular lines. That's this one and this one. So I will see the shadow of it on those two lines. So if I look from the top, I've got, come on, don't do that. Okay, I have got, let me change the color. Can I change the color? Come on, give me the pointer options, color. This component here, I'm not drawing on the line, I should draw on the line here. I've got this component, and I've got this component. So I can draw this one here, and I can get this one here. So head to tail rule, I've got 1 and 2 vectors. Using head to tail, I get my resultant out. Okay? Clear? Now watch what I'm going to do. Same vector is the same vector. I'm not changing the vector. So I asked you to break it up in two vectors, so you did that. You draw a horizontal vertical line, and you had the components out. I have got a straight line, and I've got another perpendicular line. I ask you to divide this vector into two along those perpendicular lines. So it's easy. The component of, come on, change it, change. I need to get used to it. So the component, one component lies here, and the other component lies here, which I can bring it here, and I've got that component here. It's the same vector with two different components. The previous one, the horizontal, I had horizontal and vertical lines. So I divided that vector along those axes. I have rotated the axis, and I again divided the same vector into two components. So remember, when you divide a resultant into a vector into its components, you need two perpendicular lines. So yes, two perpendicular lines. It doesn't matter where the line orientation is. In your system, remember, if you've got a complicated system, you draw axes first, and then you do all your analysis on those axes. It is not important that your axes are perfectly vertical and horizontal. No, whatever axis you define, you stick to it till the very end. Okay, I've seen many engineers in the industry, whenever they do stress analysis, they always define vertical and horizontal lines, because sometimes the solving a problem is easy if you rotate your axis. So in simple words, for a vector to be divided into two components, you need two perpendicular lines. Okay, so let's have a look now what says on the slide. Okay, so I've got a vector here, and I've got two components, that's fx and fy. We resolve vectors into components using x and y axis system. Each component of the vector is shown as a magnitude and direction. So I've got the x component here and its direction also given. I've got the y component and its direction given. The directions are based on the x-y axis. We use the unit vector I and j to designate x-y axis. So basically, you've got I and j. I is always in the direction of x-axis, and j is always in the direction of y-axis. Okay. So this is your two vectors. If you do summation of vectors, you get your resultant out. This is your outcome, and the opposite is the same. The vector, either I can put an arrow on top to show it's a vector, or I can put an I or j here. Okay, which means, what is this then? That's a magnitude. Okay, yes, that's a magnitude, because this arrow part is taken by this I here. Okay. So look here, a vector, and I've got two axes. Okay. This time the axis is rotated. So it's asking you to resolve a resultant vector into its two components along the axis, but here axis is not horizontal vertical. So it doesn't matter if your axes are horizontal vertical. It's still very easy to divide a resultant into the two components. But remember, the axes have to be perpendicular. You cannot have an axis like at 60 degree to each other or 80 degree to each other. They have to be 90 degree to each other. That is the axis, okay? The x and y axes are always perpendicular to each other. Together, they can be directed at any inclination. So you can rotate your axis, okay?